Hello guys, this video we also will talk something about the IP access control list. And we already know how to do the configuration about the ACL, right? How to make the entries, how to match the traffic, and what's the actions we can use. And this video we will focus on which is the correct location you have to apply the ACL. Because maybe when you want to use the ACL to control some traffic, for example, to discuss some message. So if the message need to be discarded, we hope we can discard it as early as possible. So we don't need some devices or link to waste the resources to force the message. But if you give the wrong location, maybe some correct traffic also will be discarded. So this one also is very important, how to give the correct application location. And here is the topology. We have two switches and connect with the terminal, and finally we'll connect with one target network. And when we apply it, we have to, for example, apply the ACL into the interface. But about the interface, we have two directions. One is inbound and another one is outbound. So which direction should be better? While the data stream is coming in and out from the switch interface, and the config ACL need to be applied to the interface. So this is a basic requirement. For example, now this traffic, the source of the message is 192.168.1.0, and this traffic need to be forwarded out. And how to discard this message? The first one we can apply on the blue interface, the outbound interface. That means when we send out the message, we will direct it to discard. We'll discard it. And another one we also can be applied in the inbound interface. When I receive this message, I will directly discard. So the message cannot enter the forwarding process. So both of the direction and the interface can match the requirement. And all of the interface can be either a physical interface or maybe an SVI interface. That means if the layer 3 interface can support to apply the ACL, and the direction of application is configured according to the content of the ACL and also the direction of the data flow into the interface. For example, here we create the configuration, right? IP access list, and we choose extended and for VLAN 10, and we add some entries to limit the traffic of 192.168.1.10 and also the same segment. So about this information, we can apply the blue one and also can apply on the red one to choose the same to choose this direction interface. And all of them, this direction can match the requirement. But if you want to discuss the message as soon as possible and you already use the extended ACL and you can match everything and without the mistake the correct traffic, so you can directly to apply on the access interface, inbound interface. This is the correct direction. But if you choose the access switch, the outbound interface, the traffic is wrong, right? Because you match the source is 192.168.1.0. So this is the first one you have to know. Choose the correct direction. And the second one, on what devices the ACL should be configured. For example, PCA and PCB. All of them have the IP address belong to the same VLAN and connect with the access switch and then connect with the distribute switch. Then the actual requirements need to be combined to determine what level of devices to apply ACL. For example, if you want to control some traffic within a VLAN, they belong to the same VLAN. That means only the access switch to help us for the message is enough. So if you want to do some control ACL, you can directly apply in the access switch. And the second one, if you want to control the flow between different VLANs, that means we need our gateway to help us for the message. And if you apply the gateway on the distribute switch, you also need to configure the ACL on the aggregation switch. Maybe it's a core switch, depends on where your gateway located. So this is the places. And where can the following ACL be applied to make the PCA unable to access PCB? For example, now we already configured the ACL and we choose the extended ACL. And the entry is sequence 10, deny IP host 192.168.1.0 to the destination 192.168.1.20, and the sequence 20 permit IP any. So we will find these two IP addresses belong to the same segment, right? So if you want to control this traffic, you have two places can be applied. The first one you can apply in the interface of the distribute switch and choose the inbound direction. And the second one you can apply the interface in the inbound direction of the access switch. And the correct answer should be option B, right? Option B is right because the data flow within the same VLAN and does not need to go through the aggregation switch. So if you apply this ACL in the option A cannot receive this message, so you cannot control the message. So this one is very important. But if we change the topology and like this one, we have multiple VLAN located on the access switch, and we apply the distributor switch as our gateway. So in this scenario, if we want the VLAN 10 cannot access the VLAN 30, and the VLAN 20 cannot access VLAN 40. So this is our requirement. And if the ACL is configured on the access switch, you need to configure multiple switch because maybe lots of switch will apply the VLAN 10 and also will apply VLAN 20, 30, and 40. So the configuration effort will take lots of effort and error prone. So in this scenario, suggest to control the data flow into the aggregation gate and you gateway devices in the distribute switch, and you can apply the ACL in the SVI interface. And about this option, you can reduce amount of configuration, and also it's easy for us to do the maintenance. So this is a suggestion because all the traffic between different VLAN must pass through the gateway. So you can direct it on the gateway to manage the control certainly. And then we can create the ACL at first, IP access list extended for VLAN 10, and deny IP 192.168.1.0.000.255 to the destination 192.168.3.0 and destination, and the wildcard mask is 0.0.0.255. And the other traffic can be passed through, so you allow IP any. And another one, you create the ACL for VLAN 20. IP access extend for VLAN 20 and IP denies the segment 192.168.2.0.0.0.255, and the destination is 192.168.4.0, 0.0.0.255, and also have to permit IP any. And finally, you have to do the application, right? And enter the SVI interface 10 and 20 and IP access group for VLAN 10 and the direction to choose inbound, and also the same configuration of the SVI interface 20, but we have to choose the ACL is for VLAN 20. So this is a basic configuration. So we have to configure, in this scenario, we have to configure the ACL under the SVI interface of the gateway switch. This is the second typical location. And the third one, like this topology, is ACL applied on the device as a proximate to the source or to the destination. For example, here we have the requirement in the PCA and PCBs how to control this traffic, right? And the requirement is now we create a standard ACL. The name is A to B. We don't want the PCA to wait to PCB. And the entry is sequence number 10, deny 192.168.1.0, 0.0.0.255. That means all the traffic of the PCA will be discarded. Not only about the PCA, the segment of 192.168.1.0/24. This traffic will be denied, and the other traffic can pass through. So, if you use a standard ACL, only can match the source address, place config on a device as approximated to the destination of the message. So this ACL needs to be applied on the switch B to discuss the traffic. What are the problems if we apply to a device close to the data source? For example, if we apply this ACL in switch A, and all the traffic from PCA will be discarded, includes the traffic we want to control from PCA to PCB. This action is correct. But if PCA want to wait the other segment, like the internet, like maybe PCC, because we already control on switch A, so this traffic also will be discarded. So that's why if you choose a standard ACL, please select the devices and proximate to the destination. So this is a standard ACL. But which scenario we can use extended ACL? If you use extended ACL, that means you can match lots of information, not only the source. You also can match the destination address. So if you use the extended ACL, we suggest to configure the device as approximated to the source of the message. So some traffic need to be discarded. You can directly discard as soon as possible, as early as possible. In this scenario, we can avoid the packets being forwarded through multiple devices in the network before being dropped on the device as proximate to their destination. Because this traffic finally will be discarded, so we hope that all the devices or the link don't need to waste the resources to forward the message again. For example, now we want to control the traffic from PCA to PCB, and now you can create the extended ACL, and the entry is deny IP 192.168.1.0 to the destination 10.1.1.0, 0.0.0.255, and the other traffic can be permitted any. And this ACL can be applied on the switch A. That means if the traffic from PCA to PCB, we will match the entry of the entry 10. But the other traffic, for example, from PCA to PCC, the traffic cannot match the sequence number 10. We will continue match the sequence 20. So this traffic also can be forwarded out. In this scenario, we can directly apply the ACL in switch A. to discuss the message as early as possible. So this is the application. And the other one, if we still have the other segment, PCC, right? And the PCC have the segment from 192.168.3.0. And now the requirement, for example, you want to control multiple message. And in this scenario, also maybe you use the extended ACL, but you can apply on the destination device. So you can control the traffic centrally. For example, here, we will show you the extended. We want to control some traffic to visit the PCB, and we add two entries. The first one, deny IP 192.168.1.0 to destination 10.1.1.0. And another one, deny IP 192.168.3.0 and to the destination 10.1.1.0. So by the principle, we say if you use extended ACL, you can apply it close the source device, right? But if you want to control PCA to PCB, PCC to PCB, and you apply on the source devices like the switch A and another one maybe is switch C, you have to create two ACL and apply them in two devices. But if you close to the destination, switch B, you only create the one ACL. It's enough because all of the traffic, both of the traffic, will visit the same destination PCB. So in this scenario, you can directly to apply the ACL on the destination device. But pay attention, maybe switch A still needs some resources to force the traffic, but finally the traffic needs to be discarded. So this also is a waste. Depends on you. If you want to control the traffic on switch A, it also can work. But you also have to add the configuration on the other devices connect with the PCC. So this one will add your work to do the configuration. But if you control same control with on the switch B, you only add one ACL is enough. So this is the application location. When you to configure the ACL, you also have to consider which devices should be applied by this ACL. Not only about the interface direction, also the first one you have to choose the correct device. And the other one, we also can support the other application of ACL, the typical one, time-based ACL. For example, we want to control some traffic within special time. In your working time, you can not visit the website, something like this. So we also can support to do ACL based on the time, and the ACL can be added within a time parameter to make them effectively at a special time. So this one we also can do. And we have two types. One is absolutely time period, and another one is periodic time period. So like the name, you can define different time to meet your requirement. And if you want to use this one, you have to make sure your device time is configured correctly. You must have the correct time, right? And all the devices should have the same time. And you have to use a clock set command in the key point mode to set the correct time. And then you have to associate the time parameters with our ACL and directly to connect with ACE. And then you can calling the ACL, apply the ACL into the correct interface, correct direction, and also choose the correct device. So later we will see one example. Now, if our company set up a web server, and the IP address is 192.168.1.100, and the server is required to provide service to the public at a specific time, the detailed requirement is this one. Employee can access but only available from 9 o'clock a.m. to 18 o'clock p.m. on weekdays, but not at any other time. The second one, the employee unit access only be available on July 20th, 2021 from 9 o'clock a.m. to 12 o'clock a.m., but not at any other time. So this is a basic requirement. And then how to meet the requirement? The first one, you have to choose give the correct device time, because now we want to control the traffic according to the time information. And how to set the time, and you have to in the key point mode to give the correct time, and then you have to define the time period, to define the time special 2 times to meet the requirement. And one we have the absolutely time and another one for the periodic time, and the key command is here, time range, and then to give the name and set the absolutely time. The absolutely time start 9 to 9 o'clock 20th July 2021 and end of 12 o'clock 28th July 2021. This is the second requirement, right? And another one, you have to set the periodic time. In the periodic time, we have to choose weekdays, 9 o'clock to 18th. And also you can set some special time from Monday to Tuesday to Friday, and also you can set every day, something depends on your requirement. And then you have to make the time to combine with your ACL. And when not within the time range defined by working time, the two configuration ACL statements do not come into effect. So if you only define the time but not combine with ACL together, that means the time is not working. So when you create the IP access list and you choose the extended ACL, the name is OA, and you will define the entries. The first entry, you have to permit the TCP any host. Any host means everything, right? Everyone can visit the destination 192.168.1.100, and we only want to allow the web service, so you have to choose the port number, the EQW time range work time. And the other traffic denies the TCP any host to visit this destination. And all the other traffic can pass through. And of course, later you also have to apply this ACL in the correct interface, in the correct inbound. Then the ACL, the time can work. So this is the basic one based on the time ACL. And you can control the traffic within the special time. And here also one practice question for you. This is a multi-choice. What is the standard ACL series number range? We have 2 ranges for the standard ACL, right? Do you still remember the answer? If you want to know the answer, please follow the next video. Thank you.
Hello guys! Now let me have a brief summary of ACL for you. About the ACL, the basic function is to control the traffic. For example, define some message to visit the destination or maybe deny to visit the destination. And about the ACL, we can divide into multiple types. And the typical type is the first one about the basic. We also call it standard ACL. And another one is extended. And about the standard one, we can control the traffic according to the source information. But if you want to control the traffic more detailed information like the source and the destination IP address, port number information, some protocol, something like this. If you want to use this function, you have to use extended ACL. And about the action, we have two types. One is deny and another one is permit. And finally, don't forget to apply the ACL in the detailed application. For example, deploy this information in the interface and decide the direction. Maybe it's inbound, maybe it's outbound. Then when the devices receive the message, I will check the raw information and finally to forward it or maybe discard it. That's all about the IP access control. Thank you.